In today's class, we will deal with some questions from chapter 13, Organic Chemistry, class 11. So, I have written one question. So, let us solve this question. The question is, what are the necessary conditions for a system to be aromatic? Well, to answer this question, we have to think about the benzene ring. Benzene ring is the parent aromatic compound. Keeping that in mind, we have to think about other aromatic compounds. So, the conditions necessary for a system to be aromatic are, there are three conditions. First condition, the molecule, the compound should be planar. I am writing in capital, planar. Number two is there should be delocalization of pi electrons and number 3, there should be 4n plus 2 pi electrons, and this n is what? N is equal to some integer. Okay, and this last one, this is very important one, important factor to determine aromatic character. This last one is known as Huckel rule. Well, so these are the three conditions necessary for a system to be aromatic. First, what? The compound should be planar. Planar means it should lie in one plane, but we cannot see whether it is lying in one plane or not. So there is a trick to determine planarity of a molecule. The molecule should be sp2 hybridized. You try to find out whether the carbon atoms linked in the compound are sp2 hybridized or not. If it is sp2 hybridized, means it will be planar. Next question, there should be delocalization of pi electron. If you think of benzene, the parent aromatic compound, pi electron, obviously there has to be pi electron, and delocalized means they should be able to move around so that resonance is possible. So this is the second condition. And third condition, there should be 4n plus 2 pi electron. So like here we are seeing pi bond. In one pi, 3 pi bonds are there. That means there are 6 pi electrons. So when a compound satisfies all these three conditions, it is then that we can say that the compound is aromatic. Now we will check some questions or compounds rather, whether they are aromatic or not by following these three rules. After knowing what are the conditions required for a compound to be aromatic, let's now solve some questions on the same topic. So I have noted down some question. The question is, determine whether the following compounds are aromatic or not, and then give reason. So first compound, it is benzene. So let's check for a compound to be aromatic, it should satisfy three conditions. First, it should be planar. To check planarity, we have to see that the carbon atoms all are sp2 hybridized. Second, there should be delocalization of pi electron so that resonance is possible. And third, it should have 4n plus 2 pi electrons, that is, it should obey Huckel's rule. So see benzene, all these carbons, they are sp2 hybridized. We have to count the sigma bonds, okay? So 1, 2 and 1 hydrogen is there, 3 sigma bonds are there, so it is sp2 hybridized, that means it is planar. First condition is obeyed here, planar. Second condition, let's check, are there delocalization of pi electrons? Yes, obviously you can see there are 3 pi bonds, so that means 6 pi electrons are there. So delocalization of pi electron, this condition is also satisfied. Next, third one, is there 4n plus 2 pi electron? This we have to check. See, here n means number of ring, so you can see there is only one ring. So when we put n equal to 1, so 4 into 1 plus 2, that is 4 plus 2, that is 6 pi electrons are there. 2 plus 2, 4 plus 2, 6. So this compound satisfies all these conditions, hence it is aromatic. This is aromatic. Write it little bit smaller so that I can complete the whole word. So this is aromatic. Next, come to this compound. This is phenanthrene. Okay. So first, is it planar? Obviously, if you will check this carbon, all of them are sp2 hybridized, so it is planar. Second, as there are pi electron, so there is delocalization of pi electrons. And number 3, 4n plus 2 pi electrons are there or not. So here n equal to, there are 3 rings, that means if we put n equal to 3, so 4 into 3 plus 12, so 4 3s are 12 plus 2, 14 pi electrons should be there. If it is there, then obviously it will be aromatic. So let us check out 2 to 4 to 6 to 8 to 10 to 12 to 14. So that means this is also aromatic as it is satisfying all the 3 conditions. Let's move on to the next one. This is naphthalene. First, all the carbons are sp2 hybridized, so it is planar. Second, pi electrons are there, so delocalization of pi electron. And third one, 4n plus 2 rule. See here, n is equal to number of rings, so 2 rings are there, so 4 into 2 plus 2, 4 2s are 8 plus 2, so there should be 10 pi electron. Let's check out 2 to 4 to 6 to 8 to 10. So this is also aromatic because it is satisfying all the 3 conditions required for a compound to be aromatic. Let's come to this compound. Okay, first condition we have to check planar. Now look at this carbon. This is sp3 hybridized. So first condition is not satisfied. This is not planar. So this is not aromatic. Let's come to this number 5. Again you come here. These are sp2, but this is sp3 hybridized. So this is not planar. So it is not aromatic. Next, let us come to this molecule. Obviously there are all the carbon atoms are sp2 hybridized, so planarity is satisfied there. Second, there is delocalization of pi electron. This condition is also satisfied. Next, the third condition, that is if it obeys Huckel's rule, that is if there are 4n plus 2 pi electrons, then obviously it will be aromatic. So let's check the third condition, 4n plus 2, that is, this is one ring, so 4 into 1 plus 2, that is 6. There should be 6 pi electrons, but we are seeing that 2 plus 2 4 plus 2 plus 6 2 to 4 to 6 to 8, but there are 8 pi electrons, which is not in accordance with this Huckel rule. So this rule is not satisfied. So out of the 3, 1 is not satisfied, hence this is not planar. So in this way we determine the aromaticity of a compound.